When I used to teach out of a textbook, and I wrote my notes, I always put a quote at the top, so that's why you see a quote from Oprah. Luck is a matter of preparation, meeting opportunity. Notice what the objective is. The objective is to find partial fraction decompositions of rational expressions. You don't have a clue what that says. Okay, you can read it, but you don't, it might as well be Greek, right? Mark Sparks does not do partial fractions. So, let me explain to you why we're doing it. You don't do it in Calculus 1 in AP Cal. But if the major that you have requires more math than Cal 1, for instance, if you're going to be an engineering major, some hard sciences require Cal 2. This is a technique that you use in Cal 2, okay? So it's going to be a one-day thing, well, today and Thursday. But we won't ever use this skill again in this course or in AP Cal. Cal 2 is where you would use it again. Not unless you're going to take Cal 2, correct. There will be a quiz like on that Monday or Tuesday before finals. That will be the last grade you have before your final exam. Now, in Algebra 2, one of the things that you learned how to do was add fractions like those. You learned how to do that. Now, here's what we're going to do. You don't have to do this, but I'm going to go down to the bottom of this page to get some more space, and I'm going to remind you what you learned in Algebra 2. Where'd it go? 2 over x plus 3 plus negative 1 over x plus 2. You learned in Algebra 2 how to add those together. So we're just going to remember how to do that. How do you add two fractions? Common denominator. What's the common denominator? No, not 6. X plus 3, I think I wrote it down wrong. That's in x minus 3, isn't it? Yep. So the common denominator is x minus 3 times x plus 2. No. What does this fraction need? It needs the x plus 2. Now, why do I do it like this? Why do I have to do both? Why? Why do whatever I do to the bottom I have to do to the top? Why? What's x plus 2 divided by x plus 2? 1. I can multiply anything in the world by 1, and what do I get back? The same thing. So I'm just multiplying by 1. I'm getting the same thing back. It's just going to look different. What do I multiply this one by? Again, I'm just multiplying by a form of 1, not changing anything except the way it looks. So what I've got here is what's my numerator? That's right, 2x plus 4. And then what's this numerator? Minus x plus 3, which equals, clean her up, x plus 7. Now I'm going to multiply the bottom out just for a reason here. X squared minus x minus 6. That, ladies and gentlemen, is this. Right?
So what we do is cancel out x minus 3 and x minus 2 on both sides, but the denominator and numerator on opposite sides, and when we multiply it, we cross them out, yet area, and
now, so what you did in Algebra 2 is you added those to get this, right? What I'm going to teach you how to do is to take that and figure out what fractions you added to get it. So we're just going backwards. It's not hard. It's not hard. This is called partial fraction decomposition. We are decomposing or breaking down a rational expression. Oh, quit complaining. This and this are each called a partial fraction because they are part of this. No. No. What you see on the bottom half of this page, all of this right here, if you read through this right now, you would think it was Greek, and it might as well be because you wouldn't understand one piece of it. These are the rules for partial fraction decomposition. What we're going to do is we're going to skip this, we're going to work the problems, then once we've worked the problems, I'll come back and say, hey, do you remember? And that's why the rules work, okay? So go to the next page. All right, guys, we got to move, okay? This example 1 is the problem that was on the front that you do already know the answer. You just have to figure out how to make it work. Before we do it, don't write anything down. I need you to think here. What's A?
A is 2.
A is 2. Why does A have to equal 2? That's right, because if these are equal, then the x squared stuff over here has to equal the x squared stuff over here. So A has to equal 2. What's B? 6. What's C? Please don't forget how to do that. Okay? That? Please don't forget. The first step in writing a partial fraction decomposition is factoring the denominator. You can do that. How many things are we multiplying together in the denominator? 2 things. What are they? X minus 3 and x plus 2. Each one of those is called a factor. You buy that? Factors are just things that are multiplied together. Now, so you said we have 2 factors in that denominator. So our answer is going to have 2 fractions. One of them is going to have x minus 3 as the denominator. The other one will have x plus 2 as the denominator.
Is it always a plus?
Yep. I will flesh that out a little bit shortly. Now I want you to look at x minus 3. Is the expression x minus 3 constant, linear, quadratic, cubic? X minus 3. Linear. Why is it linear? Because the biggest exponent is 1. If the denominator is linear, then your numerator is going to be constant. And I'm just going to put a number. Constant is a number. No cross multiplying. X plus 2. Constant, linear, quadratic. What is it? Linear. So your numerator will be constant. You'll figure that out in just a minute. I can't use A because I've already used it. I'm just going to use B. Folks, if you can get to this step right here, the rest of it's cake. All right? So you've got this equation that's got fractions all in it. Any idea how we could get rid of all those fractions other than just erase them? Multiply by the common denominator. X plus 2 times x minus 3. Just to indicate that they're different. That's all. So what we're going to do is we're going to multiply every term in that equation by the common denominator. Well, essentially, it's really this, right? When I multiply this by this, what happens? Do you notice that the x plus 2 and the x minus 3's cancel out? And I'm left with x plus 7. What happens when I multiply right here? The x minus 3 cancels, so what am I left with? Times a. Because the x minus 2 times x minus 3 times x plus 2 in the numerator, and an x minus 3 times x plus 2 in the denominator.
So it just stays the same values. Like, no matter what problem that would go to the same.
I don't understand.
Like, no matter what problem we do, when we multiply that
Mm-hmm.
by that
Mm-hmm.
denominator, it'll always stay the same because it's the same on top. You ever seen that?
I think the answer to your question is yes. Okay. What happens when I multiply here? The x plus 2 cancels out, so what am I left with? B times x minus 3. Not exactly with the a and b, but yes, you have. In solving equations, yes, you did this. Now, so you say, all right, fine, what do we do from here? We're trying to figure out what a is and what b is. So, this is on the part that I told you, don't forget how to do this. We're going to distribute the a and we're going to distribute the b. This is algebra 1. If we distribute the a and distribute the b, what are we going to be left with? You got to tell me if you get stuck. Now, on the right side, I'm going to combine like terms. Now, notice ax plus bx, those are like terms because they both have x, but I can't add a and b. So here's the way I'm going to write it. I'm going to write it like this. I factored out the x out of ax plus bx. I just factored out the x. Did I lose you?
Yeah.
Okay. I had this, ax plus bx, right?
Yes.
And I factored the x out. I just put the x on the back.
But what do you do with the 2a and 3b?
I'm not there yet. Give me a minute. Gotcha. Okay. Now, what are these? Well, they're constants. They don't have a variable with them at all. They're just numbers. So I'm just going to write them down. Tristan, did you hear that? I'm just going to write those down. Now, don't forget how to do this. Look on the left side. What's the coefficient of x? 1. Look on the right side. What's the coefficient of x? So 1 has to equal a plus b. Question. You bet. You bet. I give you x squared plus 2x plus 3 equals ax squared plus bx plus c. What's a have to equal? 1. What's b have to equal? 2. What's c have to equal? What's a plus b have to equal? It's the coefficient of x. So what's the coefficient of x over here? 1. So a plus b has to equal 1. Now, what's the constant on the left side? 7. What's the constant on the right side? 2a minus 3b. Yep. So 7 has to equal 2a minus 3b. Ladies and gentlemen, you have a system of equations. Oh, wait! I like systems of equations. Substitution, elimination.
Yeah, you're a math teacher. You're supposed to do that stuff.
I have such a complicated relationship.
Sarah has a complicated relationship with systems of equations. It'll be all right. It'll be all right.
I would work papers and papers going all the way down, and then I'd make a mistake, and I wouldn't be able to find it.
Where did I lose you? Do you understand here why a has to equal 1? Same thing. Same thing.
I think I focused on this and then I stopped because I thought, are we going to the problem? We're not even finished yet.
No, we're not finished yet. See here, the coefficient of x is a plus b. The coefficient of x over here is 1. So those have to equal each other.
They're set equal to each other.
Yes, because it says they are equal to each other, because there's an equal sign sitting right here. Here, the constant, right, the constant on that side is 7, the constant on this side is 2a minus 3b. So those have to equal each other because it says they're equal to each other. Go ahead.
If it was 2x, a plus b would be equal to 2.
Yes. Yes.
All right.
Where do I put the x squared plus?
Don't put this anywhere. Pretend it didn't happen. Don't put it anywhere. Don't put it anywhere. Don't put it anywhere. Life is good. Okay? How do we solve that system?
I don't,
Ah! I could isolate something and substitute.
Oh, or you can multiply and then take out the base.
Or
Top by 3.
Or I could multiply the top one by 3. Because, okay, Mia.
Or we can just circle those and say we're done.
I don't like the last thing you said. Why did you pick multiply by 3?
Because then you'll have plus 3b and minus 3b, so we'll just cancel out.
Yep. If I multiply that top equation by 3, what do you get?
Oh, that's not. Okay, you just gave us these. The numbers are just prettier.
What's A?
2.
A is 2. If A is 2, what's B? Negative 1. Mystery. I'm going right here. 1 equals A plus B. So B is negative 1. Now all I'm going to do...
That was extensive.
Yeah.
That was a lot of work for a little answer. So how do we just plug it in? That was awesome. Let's do the next one. What?
dang it, I wasn't listening.
Okay.
Oh, you
Okay, well that tells you better listen to Mia then.
That's right, boys.
By golly. Okay, so just a minute. So here's what we've got. And your answer needs to look like this. X plus 7 over x squared minus x minus 6 equals. What did we figure out A was? 2. 2 over x minus 3 plus negative 1 over x plus 2. You just figured out what two fractions you add together to get that first fraction. You did it. Well, I did it and you watched. But you quit. It goes fast once you get the hang of it. Now listen here, Ebner. I need to show you something because I think it was me. Somebody asked, does this always be a plus? But look, here, instead of saying plus negative 1, I could just write this as minus. It doesn't matter. It's the same thing. All I'm saying is this could end up being a minus if you get that second variable to be a negative. It's the same thing. Same thing. Same thing. Question. There, I'm teaching you the shortcuts.
This is a shortcut?
Oh, would y'all shut up?
Hey, I got that that's on video. I'm gonna tell my mom.
Go ahead.
140, I'm writing that down.
Example 2. Let's try it again. What's the first thing we're going to do? Factor the denominator. Do it.
I think I lost you on the x.
I like that answer. I do too.
Okay, if you can't factor that.
I was a kid. Hey, see you later.
Okay. We're going to walk through this slowly and carefully. You get it. I promise. Students can do partial fractions. It just takes a few examples. Just take some practice. How many factors are in the denominator?
2.
There are 2. What are they? X and x minus 3. So how many fractions will we have in our decomposition? 2. One of them will have x as the denominator. The other one will have x minus 3 as the denominator. Now we have to decide what to put in the numerator. That's right. Let's look at this x. Is that constant, linear, quadratic? Linear. So the numerator has to be constant.
X squared.
I will show you. What's x minus 3? Linear, so the numerator has to be? Okay, so what if the denominator had been? This is quadratic. So what do you think the numerator has to be? Linear.
So they're like, oh, that's just terrible. Oh, erase that before it gets about right. Yeah, that's kind of funny. We can cover that one. Cover that.
Look, if the denominator is linear, if the denominator is linear, the numerator is constant. If the denominator is quadratic, the numerator is linear. If the denominator was cubic, the numerator would be quadratic. If the denominator was cubic, the
Oh, see, it's the all the way down.
Constant is just something that, like, it doesn't have like an extra.
correct, correct.
That's what I was
Now, what is the relationship between the degree of the numerator and the degree of the denominator? Right. Whatever the degree of the bottom is, the numerator is 1 less.
That makes sense. It just looks hard. It is.
You-
It should say.
No. Okay. If it was, yes, ax cubed. That's right. That's exactly right. Seth said, what if the bottom was quartic, degree 4? And Danae said it'd be ax cubed plus bx squared plus cx plus d. That's exactly right. Well, you'd start with an x to the 4th. Yep. Get rid of the fractions. What are we going to do?
Like x minus 3.
There you go.
Break time. This is
We
my
can brain
homework.
break after this.
If I was doing my own homework right now, it'd be like snack time or juice time or
Juice time.
like juice.
Distribute x times x minus 3. What do you get? Negative 6 equals a times x minus 3 plus bx. Distribute. Distribute and combine like terms. Questions here? Listen, I'm going to have to keep writing down here, so that's why I marked through that. So we're going to have negative 6 equals, if we combine our like terms, what's this next line going to look like? Those are the linear terms, correct?
A plus B, and then take out X.
That's right. So I'm going to put a plus b times x. And then, okay, yes, yes. So what does a plus b have to equal? Why 0? Because there's no x on the left. Finish it. What else? Negative 3a has to equal negative 6. Because the constant over here has to equal the constant over here.
So you just multiply the top, I think.
What's the bottom?
Oh, my bad. Yeah.
Look at that bottom.
You really just went time, so.
What's a? A is 2.
Oh, wait, why is it plus B? Sorry.
No x on the left side. If a is 2, what is b? So the equation was negative 6 over x squared minus 3x. It was a over x plus b over x minus 3. And you just decomposed that fraction. What do you want me to do? Start with the hardest one I can find?
Well,
Yeah,
that'd be nice.
I would like to do a hard one before class. So if you do a hard one before.
Now remember, you can do this. You could write this. Same thing. All right. I want you to work example 3. Now listen, it doesn't matter if you put the x plus 3 or the x plus 1 first, right? That doesn't matter. Listen, if you put x plus 1 first, okay, then the number I get for A is the number you're going to get for B. And the number I get for B is the number you're going to get for A. But the answers are still going to look the same. I'm going to go through this fairly quickly. We're multiplying by x plus 3 times x plus 1. So you get what x plus 1 equals. So far, so good? If we distribute, we get x plus 1 equals ax plus a plus blah, 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 this right here. You got a plus b times x. plus a plus 3b? So if you did it the way I did it, you got that as your system? If you did it the way I did it, if you put x plus 1 first, then your a's and our a's and b's are going to be swapped. Who did it this way with the x plus 3 first? Okay, so what did you get for a? What did you get for b? I would probably multiply this by -1. So that would give me negative a minus b equals -1. And, well, that works. And then a plus 3b equals 1. So that'd be 0. That'd be 2b equals 0. So a is 1, b is 0. A is 1, B is 0. What does this look like in an answer? Say again? Yeah, this is 1 over x plus 3. What's 0 divided by anything? 0. Wait a minute. Wait a minute. Look right here.
You're telling me, idiot. Why couldn't you point that out 20 minutes ago?
Isn't that just 1 over x plus 3?
Oh,
Yeah.
If that happens, we can solve it.
Of course.
What about yank your chain?
I did yank your chain. Yes, I did. The answer is 1 over x plus 3.
But what is it? X plus 3.
It's this equals this. That's your answer. Shh, I can't hear. Go ahead.
Shouldn't you, like, break it? Other linear function?
I did. That's when we did the x plus 3 and the x plus 1 as the denominators. That's how we got the a was 1 and the b was 0.
Okay, but like this do like instead of keeping it x squared plus 4x plus 3, can't you put 1x plus 1 over x plus 1 plus 3?
Yeah, I bet that. Like that.
I'm going to stop this because I'm trying to figure out a question. The degree of the numerator, 4. Degree of the denominator, 3. Notice the degree of the numerator is higher. Now, I want you to, It just means you got more work to do. Go back down memory lane. In elementary school, you were taught that that was not an okay answer. You were taught that you had to write it as a mixed number. That's what we're going to do here. We're going to write it as a mixed number. Now, do you see here, when the numerator was bigger than the denominator, you could write it as a mixed number? Here, when the degree of the numerator is bigger than the degree of the denominator, we can write it as a mixed number. What if they were equal?
What?
Right. So, if the degree of the numerator is equal to or bigger than the degree of the denominator, we got to rewrite that as a mixed number, which involves, guess what? Long division.
No.
Long division. We cannot do synthetic division unless we are dividing by a linear term.
Can we just do from looking at it? X3 into X4, 1 and 1/4 times.
1 and 1/4. No, it doesn't work that way. Okay. Do you notice that you've got more than half a page empty? Do you notice that there was a reason for that? You are not gonna die. Oh, shut up. You are not gonna die. I will remind you. I will remind you. What I teach my Algebra 2 students is go over to the side and make you a thinking box. And I'm going to show you what I'm talking about. This is just where they go to think. Now, what you're going to do here is you're going to think, what's x to the fourth, first term here, divided by first term here. Not 1. What's x to the fourth divided by x cubed? X goes in x times. Isn't x to the fourth divided by x cubed equal to x?
Oh man, this is gonna get messy.
Now, some teachers don't do this the same way I do in terms of where I put that x in the top in the answer. I like to line up my like terms. Some teachers just put it at the beginning. I just like to line up my like terms. It just keeps my head straighter. Once you put a number up there, what do you do with it? You remember?
You have to you subtract.
Look here. What do? 5 goes into 7. What do I do with that 1? What do I do now? I multiply this by this. Right? So I'm going to multiply this by this. All right, x times, y'all hush.
Oh my gosh.
Oh, for heaven's sake.
Please tell me we're subtracting.
And then we're gonna, look, 1 times 5 is 5. Then what do we do with the 5? We subtract, which means change the sign. Change the sign. All right.
Oh, that's actually better.
Gone. Gone. What do we do next?
Bring it down.
Bring it down. How many terms are sitting here?
3.
How many terms are sitting here?
2.
2. Let's go ahead and bring down the last term.
Well. Now we just see how many times we go.
That's right.
So we don't use it.
Now I've got to do x squared divided by x cubed.
Oh.
You're done, right? Because the degree of x squared is smaller than the degree of x cubed. You're done. That's the remainder.
That is a likely remainder.
So that whole mess up there that we started with is x plus, here's this x, right? This is the remainder.
So it's plus that, over that.
Mm-hmm. So a few of you liked long division.
Crazy heads.
Do you have questions about how we got to this point?
Wait, is that x plus separate?
Yes. If you have 5 over 2, that's 2 and 1/2. Those are separate.
2x plus is just wait, why is it separate?
If I give you 5 halves and tell you write it as a mixed number, it's 2 1/2, meaning 2 plus 1/2.
Right, okay.
So the 2 and the 1/2 are separate. It would be x squared. It would start with an x squared. All right. Now, what in the world do we have now?
It looks like the numerator is the denominator.
Indeed, the degree of the numerator now is smaller than the degree of the denominator. So now we do a partial fraction decomposition on that.
But we do that next class.
Well, yeah. Now, so your answer is going to look like, when you get this all finished, x plus whatever this partial fraction is, okay?
Oh,
There you go. All right, now listen to me. I'm going to write down the assignment. You are not ready to do the assignment, but I would really encourage you to try to do the first one or two before you come back on Thursday, okay?
That's on our textbook.
Just a minute. The homework is out of your textbook. Let me give you the whole assignment, but understand, you cannot do the whole assignment, all right? It's on page 563 in your text. 17, 21 through 27 odd, 31, 33, and 43. That's 8 questions. Again, you cannot do them all. You can do 17. You can do 21. And folks, that's all you can do. Tonight or tomorrow night. 17 and 21. Try to do those 2. Okay? Just 2.